right, some word problems here. It says a tree casts a shadow of 20 meters when the angle of elevation of the sun is 23 degrees. Find the height of the tree. So let's say I make the tree over here, and it casts a shadow of 20 meters. When the angle of elevation of the sun, when they say angle of elevation or when they say angle of depression, they're always the bottom angle. So this is 23 degrees. It says find the height of the tree. So I'm looking for the height of the tree. This is our tree. Let's pretend like it looks like a Christmas tree. There we go. It's a Christmas tree. Okay, but it's outside. All right, so I'm wondering what the height of the tree is. Well, this is a right, we can assume that this makes a right angle with the ground. So remember SOHCAHTOA. All right, so from 23 degrees, this would be the opposite side, and this is the adjacent side. So I'm going to use tangent, and I could say that the tangent of 23 degrees is equal to the height of the tree divided by the adjacent side, which is 20 meters. So to solve this problem, I just multiply both sides by 20. So I get the height of the tree is 20 times the tangent of 20 times the tangent of 23 degrees. So I say 20 times tangent of 23, and I get 8.49. This was kind of tricky. Find the height of the tree. So we'll say it was in meters. We would say it's 8.49 meters. Now on your test they might say round to some blah blah blah, but they didn't really tell us. So we'll just say the answer we got. I was doing it to 2 decimals. All right, let's look at our next problem. It says a straight trail with uniform inclination leads from a lodge. So here's your lodge down here, okay? So a straight trail leads from the lodge, which is at an elevation of 700 feet. It leads to this mountain lake. So here's our beautiful mountain lake. And it has an elevation of 8,000 feet. So what I'm going to do is make a right triangle out of this little story. So here's your trail, you know. I love to go wandering along a mountain track. Anyway, so there you go. And what they ask me is, what is the length of this trail? So I'm trying to find x, because this person's walking from the lodge that had an elevation of 700 feet to this mountain lake that has an elevation of 8,000 feet. What is the difference between 8,000 minus 700? I believe it's 7,300, but just so you'll believe me, we'll just go ahead and use our calculator. 8,000 minus 700 is equal to 7,300. So that's how far we went up. Like that was the change in elevation, because we were at 700 feet and we went all the way up to 8,000. So this would be 7,300 feet. They ask me, what is the length of the trail? All right, so this is the right angle, and I'm trying to figure out how long that this side is right here. What else do we know? What's the length of the trail? Oh, what I didn't say in the problem, which I should have said, is a straight trail with a uniform inclination of 12 degrees. Sorry, I was thinking I didn't have enough information. I forgot to put that on here. It has a uniform inclination of 12 degrees. Sorry, I had to tell you that. So we know that the inclination is 12 degrees. That's how much this is here. So to figure this out, from the 12 degrees, this is opposite, this is hypotenuse. So in the SOHCAHTOA land, here's my angle. I know opposite, and I'm trying to find hypotenuse, so I'm going to use sine. So I would just say the sine of 12 degrees is equal to opposite, which is 7,300, divided by x. If what you're trying to find is in the bottom of the fraction, you can, algebraically, you'd multiply both sides by x, divide by sine of 12, but it's always true these guys just swap places. So it's x is equal to 7,300 divided by the sine of 12 degrees. Let me make can't see that. Yeah, now you can. And we just do that on our calculator. So I just go 7,300 divided by the sine of 12 degrees. And I get that that mountain path is 35,111.06 feet. So you're going to have to take a pretty good hike to get there. But 35,111.06 feet. It says to the nearest foot, so I guess I would say it's 35,111 feet. That would be our answer. Thanks.